Hello everyone. In this session of DSCH, we will design a 4x1 multiplexer. Now before designing a 4x1 multiplexer, let us understand what exactly a multiplexer is. Now a multiplexer is a digital circuit, or you can say combination logic circuit, which has multiple inputs and single output, and some selection lines or control lines. Now if the number of inputs will be 2 to the power n, then the number of control lines will be n. So the control lines controls the flow of input to the output. At the same time, only one input can be seen at the output. Now this is a design of a 4x1 multiplexer where number of inputs will be 4 and number of output will be 1, and the number of selection line will be 2, as 2 to the power n is equal to 2 to the power 2 is equal to 4. So the number of selection line will be 2. Now with 2 number of selection line, the number of possible combinations will be 4, 0, 0, 0, 1, 1, 0 and 1, 1, or A complement B complement, A complement B, AB complement AB. Now the output equation can be written as y is equal to P dot A complement B complement plus Q dot A complement B plus R dot AB complement plus S dot AB. That means when the selection line is 0, 0, then P input can be reflected at the output. When the selection line is 0, 1, then Q input can be reflected at the output. When the selection line is 1, 0, then R can be seen at the output, and when the selection line is 1, 1, then S can be seen at the output. Now let us quickly design the 4x1 multiplexer on the DSCH screen. Now we will drag two input for selection lines. First one is A, second one is B. Now connect the input with the help of a wire. Now for A complement and B complement, we need two NOT gates. Connect wire at the output of the NOT gate. Next part is, now as there are 3 variables in each term, so we need a 3 input AND gate. And how many number of AND gate we need? We need 1, 2, 3, 4. 4 number of 3 input AND gate. And at the same time, we need OR gate also. So how many number of OR gate? We need 4 input OR gate. So first take 3 input AND gate. Make 4 copies. As we don't have 4 input OR gate, we will use 2 input OR gate and make it as a 4 input OR gate. Connect these gates with the help of wires. Now we need an LED at the output, and the output is Y. So this part is ready. Now we have 4 inputs. The first input is P from the gate 1. Second input is Q from the gate 2. Third input is R and fourth input is S. Sorry, this is P, Q, R, and the last one is S. Now you can see we have given inputs to all the gates. Now we need to control these inputs. So P input will be seen at the output when the selection line is 0, 0 or A complement, B complement. Q will be seen at the output when the selection line is 0, 1. For R, 1, 0, and for S, 1, 1. So our design is ready. Press the run simulation button. Make it all 1. Now you can see the selection line is 0, 0. Change the value of P from 1 to 0 and you can see the output is changing accordingly. But output doesn't depend on Q, R and S. Now let us change the selection line as 0, 1. Now you keep on changing the value of P, output doesn't change, but output will change when you will change the value of Q. Let us check. Now you can see the output is changing according to the value of Q. Now in the same way, change the selection line to 1, 0. Now look at here, the output depends on the input R. Whatever may be the value of P, Q and S. And for the last selection, it depends on S. So in this way you can see the 4x1 multiplexer can be designed.